Lesson 3.7, Mixed Operations. This unit is all about multiplying and dividing fractions, but not so long ago in Unit 1, we focused on adding and subtracting fractions. One of the key differences in Unit 1 is when we talk about adding and subtracting fractions, we need to start by having a common denominator. And if we don't, then we need to establish one before we can go any further. When we talk about multiplying or dividing fractions, we don't need to start with a common denominator. But some of these concepts will become clear as we work through these review problems. Let's get started. In problem 1, 4 over 5 times 8 over 9, I'm first going to see if there's an opportunity for using cross-canceling. 5 and the 8, no, there's not a common factor other than 1 that go into both. 4 and 9, no, nothing there either. So let's multiply across the top. 4 times 8 is 32. Let's multiply across the bottom. 5 times 9 is 45. And even though those numbers are a little bit larger than we're used to seeing, that is our simplest form final answer. Number 2, 1/4 plus 7/8. Remember, when we add or subtract fractions, we need to start with a common denominator. In this case, I have the 4 here and the 8 here. I try the larger one first. Will the 8 work for the 4? Yes, it can. 8 can work as my common denominator, so I can leave this alone, and I need to rewrite 1 over 4 as something over 8. What I do to one side, I must do to the other. So if I want to rewrite this as an equivalent fraction with 8 as my denominator, then what I do to the bottom, multiply by 2, I must do to the top, multiply by 2. 1/4 gets rewritten as 2/8. I'll add 7/8. 2 plus 7 is 9. The denominator 8 remains what it is. 9/8 is improper, so I'll convert this to a mixed number. 1 1/8 is my final answer. Number 3, 7/10 minus 2/5. Again, I'm subtracting fractions here, so I need to start with a common denominator. I'll look at the larger one first and test that out. Will 10 work for 5? Yes, it can. So this fraction is already good because it has the denominator I want to work with. I need to rewrite 2/5 as something over 10. What I do to the bottom, multiply by 2. I must do to the top, multiply by 2. 2/5 gets rewritten as 4/10. Now, subtract my numerator. 7 minus 4 is 3. Keep my denominator the same. 3/10 is my final answer. 1/2 minus 1/3. I'm subtracting fractions. I need a common denominator. 3 is the larger of the two denominators. Will 3 work for 2? In other words, can I take 2 and multiply it by something to get 3? No, I cannot. So 3 is out as my common denominator. So next I'm going to go through multiples of 3 to see the first one that could work for 2. 3, 6, 9. Did you hear a winner already? If you said 6, you were correct. So I need to rewrite 1/2 as something over 6 and 1/3 as something over 6. What I do to one side, I must do to the other. In the case of 1/2, if I start with the denominator of 2 and want to rewrite it as an equivalent fraction with 6 as the denominator, I've got to multiply by 3. Do the same up top. 1/2 becomes 3/6. For 1/3, if I multiply the bottom by 2, I must do the same to the top. 1/3 gets rewritten as 2/6. 3/6 minus 2/6. Once the denominators match, just let the numerators do the work. 3 minus 2 is 1. 1/6 is your final answer. Number 5, 3/4 multiplied by 7. This should be familiar. This is what we've been up to here in this Unit 3. When you're taking a fraction and multiplying it by a whole number, remember, just rewrite that whole number as itself over 1. So 3/4 multiplied by 7 over 1. Any opportunity to use cross-canceling? No. So I'll simply multiply across the top. 3 times 7 is 21. Multiply across the bottom. 4 times 1 is 4. 21/4 is improper. So we will simplify this by converting it to a mixed number. 4 goes into 21 how many times cleanly without going over? 5. Denominator stays a 4. What's the leftover amount? Well, 4 goes into 21 5 times. 4 times 5 is 20. The difference between 21 and 20 is 1. 1 is the leftover amount. 5 1/4. Number 6. They saved the easiest one for last. The denominators match. So just let the numerators do the work. Keep the denominator the same. And we know 4/4 is a friendly whole. 1 all day. Moving down to some word problems here. 13. A full carton of juice contains 5/6 of a gallon of juice. It is now 1/3 full. How much of the juice is left? Okay. Remember, with word problems, we gotta visualize. You know, I love making these three-dimensional boxes when I can. And I was hoping that this was going to be a juice carton, but really it's not. I've got to do more of like a triangular piece at the top here. That's not too bad. And then you got the little valve there where you open and close it. OJ, lovely label, probably a Meyer brand. And let's get back to the problem. When this is brand new and full, it's got 5/6 of a gallon of juice. It's now 1/3 full, so how much is left? So we're trying to figure out what's 1/3 of 5/6 of a gallon. When you see that word of, what operation are you thinking? Adding, subtracting, multiplying, dividing? 1/3 of. If you said multiplying, you were correct. We're trying to find what 1/3 of 5/6 is, or 1/3 multiplied by 5/6. No opportunities for cross-canceling, so we will multiply across the top, multiply across the bottom. Get a final answer of 5/18 gallon. 5/18 of a gallon. 14. Shelton finished the dash in 4 3/4 seconds. Willis finished in 5 1/8 seconds. How much faster is Shelton than Willis? How much faster? So visualize the situation. It's a race. They both ran the same amount. Maybe it was a 50-yard race. And actually, this would be pretty fast for 50 yards, so it's probably not that long. Shorter than 50 yards. Anyway, Shelton completed it in a shorter amount of time, so he was faster. And we're trying to figure out how much faster was Shelton compared with Willis. So what operation are you thinking? Are you thinking adding? Are you thinking subtracting? Are you thinking multiplying? Are you thinking dividing? We're comparing two amounts, trying to find the difference between one and the other. And if you heard me say difference just now and thought subtraction, you would be correct. So the problem here is finding the difference between 5 1/8 minus 4 3/4. Well, to do this problem, where we're subtracting mixed numbers, we still need to start with a common denominator. In this case, we've got an 8 here and a 4 here. Let's test out the larger of the two. Will 8 work for 4? Yes, it will. So for now, leave 5 1/8 alone, and let's rewrite 3/4 as an equivalent fraction with 8 as the denominator. What I do to the bottom, I must do to the top. So if I want to rewrite this, I multiply 4 by times 2 to get 8, 3 times 2 to get 6. So 3/4 gets rewritten as 6/8. Good. But now, are we able to subtract 5 1/8 minus 4 6/8? Not yet. Not yet, because 1/8 is smaller than 6/8. We've got to borrow from the whole. Remember that analogy of being at the arcade and all your favorite video games take quarters instead of dollar bills. So you got to go to the change machine and convert your dollar bills into quarters. That's what we're doing now. The 1/8 needs help. It needs help from the whole. So big 5 here says, I will give you a whole. And so big 5 becomes big 4. And the whole gets added back into the fraction in terms of what it needs, which is 8ths. So the whole number goes down by 1 whole. The fraction goes up by a whole, or 8/8. So 1/8 plus 8/8 is 9/8. Now we can do business and perform subtraction. The whole numbers cancel each other out, 4 minus 4. The fraction's 9/8 minus 6/8. When the denominators match, let the numerators do the work. And we get a final answer of 3/8 of a second.